Now we are ready to discuss the if statement. And what really makes a program is the if statement and what's generally known as conditional execution. So normally in our program we just feed it instructions one at a time, and that's fine. But if we didn't have the if statement, our programs wouldn't be able to do very much. All we could really do is some basic numerical calculations. And so what happens is with the if statement, we generally take in input from some source that we don't know ahead of time. It's usually a user typing or maybe from a computer network. But in this example, we'll go ahead and just hard code the value for our if statement. So we take that value, we do some sort of comparison within the if statement, and then we execute a new block of code. So let me give you some working knowledge of that. We have our, we'll get rid of some of this extra stuff, and we'll just continue work with our integer I. And I should note, maybe I didn't make it clear in the previous videos. So this is our base program we're working with. We have our integer I. We set it equal to the value of 5, and then we're going to print it. So let's start by running that. And that runs, and that's all fine. We have I equals 5. Okay. So you may be tempted to, later on in your program, use I again. And then what you'll see is that gives you an error. And then we can go ahead and debug that, but we know the reason for the error, so we do not want to run the last build. And then see, our error specifically says int I redefinition. So you declare your variables once. Typically, you want to declare them at the top of your program, and that's historical. We're programming in C++, which you can technically declare a variable anywhere, but you'll see a lot of what's known as the style. So the style is you may be able to, on a technical level, do things a bunch of different ways, but when you're programming with a certain style means you arbitrarily stick to a certain convention. So that convention we're going to use is to put all the variables at the top. For one, it makes the program a little bit easier to read and to keep track of all your variables. And if you work with older code, you'll be used to that style, so you don't get in the habit of declaring your variables everywhere. So once we give it a value, if I want to give it I equals 11, I equals 15, that'll work because we're not redeclaring, we're just giving our variable a value. So now we see I equals 15. So not to spend too much time on that, let's move on. Okay, so we know at this point I equals 5. And then so what the if statement does is it's a test. Say we didn't know what we knew, if we knew, and actually let's instead of using I, let's start giving some of these things different names. So we'll say age equals 25. Actually, let's do this. Let's give it 18. And so let's pretend that instead of hard coding that 18 in there, our program said to the user, tell me your age. So what an if statement does is it performs a test. So the general form of the if statement is you have your test you want to do, and so you write if, and then within the parentheses here you do some sort of test, and I'll go through the different operators that you can use to do a test. And then if that is successful, if what's in the parentheses is true, the next block of code runs. So let's say if age equals 18. And so this is a pretty common source of mistakes with programming, is when you're assigning a variable a value, you do a single equal sign. When you're doing a test to see if that variable equals a value, then use the double equals. So keep that in mind if you ever have a problem in your program, and you don't know quite what's wrong. What's interesting about the single equals within an if statement, that won't cause your program not to run. It'll cause problems later down the road. So you might hit the play button inside of Visual Studio and it'll compile, and then you think everything's great, and then it kind of acts funny and it doesn't do exactly what you think it's going to do around your if statements. That's one of the first things to check. So let's go ahead and write a simple program here. Okay. So what happens here is we have our if statement. If age equals 18, so what the program will actually do is look at that and say, is age 18? And then because we know age is 18, it'll run this next piece of code. So let's see that in action. Okay, so we now know that it's going to run there. So another part of the if statement is the else. And so what will happen is if so if this condition is met in this first piece of code, then this second does not execute. So we know age is 18, so let's go ahead and run it. And then we know that we're an adult. So as you notice, this second, and I went through that a little fast, let me go and do that again. So we know based on this piece of code here that you are now an adult. This second part did not execute because this one was true, so the other one didn't need. So you can read it pretty plainly in English. If condition is met, then do this. Otherwise, do this. And because the first condition was met, we don't need to do that stuff at the bottom, and the program will just run it after that. So some of the other ways to what's known as some of the other operators are you can do that are the typical is the double equals, which means equals if age equals 18. What you can also do is if age is greater or equal to 18, and so that works out for this example. So if you're greater or equal to 18, then you're an adult. Otherwise, you're a child or you're not 18 yet, or however you want to phrase that. And then we can see in this example that we're still an adult because we've said if greater or equal to 18. So now let's start doing some things that will make this this else execute. So let's say 17. And then because we've changed that, the code, as I mentioned before, executes one at a time. So we have our age is set to 17. Then when we go to check our age, is it greater or equal than 18? No. So we say else. So if the condition is met, execute this line. Well, it wasn't met, so we say otherwise, execute this. And then so that's what gets executed. And the main ones you'll be working with are, let me put this as a comment. You'll have the double equals, which means equals. You can have greater or equals. You can have less than or equals. You can have less than or greater than with no equals. You can say, and the difference is just from your days in algebra, you should probably have a general sense of what they mean. Greater than and less than do not include that number. Greater than or equals or less than equals include the number that you're testing against. So in those cases, it would evaluate true. One more thing here. Let's go ahead and so we get some proficiency typing all this out. Let's start a new example. There's another a thing that you can do with if statements, which is called the if-else. So previously we had done the if statement, and then we added else. But say you have more conditions. You don't want just the two condition where you say if and else. You can do an if-else. So the general setup for that is you have our first condition. Well, if that wasn't met, then you do else if second condition. And if that isn't met, then we have our last condition. So let's set up a program here. Let's do another example. Let's say, we'll say miles per gallon. So we have a car and it has some value for its miles per gallon. So we have our integer MPG. And actually, let's more realistically, a car's miles per gallon value is not going to be an integer, it's going to be a float. So let's use a real world value here for float. And then say we have a really energy efficient car. It gets 35, type that correctly. Okay, so MPG equals 35.5 miles to the gallon. And this is our syntax here. Let's make sure we always put the variable we're assigning to on the left and the value on the right. And then so if we have if miles per gallon is greater than 30, we'll say that the car is efficient. So that's our first conditional test. Our second will be miles per gallon, we'll say less than 20. And then last, actually I wrote that incorrectly. There's no parentheses. Okay, so note the mistake I made earlier. So you see how with these if statements there's a condition to test. With the else, it will always match every condition that hasn't been specified previously. So so there is no parentheses around that. So in this example, we have our miles per gallon. If it's greater than 30, you have an efficient car. Else, if it's less than 20, our second condition, you have an inefficient car. And then last, we if it's another condition, so that would mean that it's between if it's greater than or equal to 20 or less than or equal to 30, then you have an average car. And so we know because this value is 35.5, we're going to have an efficient car. So let's go ahead and run that code to make sure that we understand that. Okay, you have an efficient car. And just to test that these all work correctly, let's go ahead and give them some new values. Let's say 15. So this should mean an inefficient car. And then we have an inefficient car. And then let's have an average car. Let's set that to 25. And then we have an average car. So that's the if statement. That's the really the basis for programming is having those conditional statements and being able to make decisions. As always, if you have any questions, make sure to email me, or if you'd like, you can put comments in the videos. Vimeo is an external site to IRSC, so you will have to register an account. But if anybody has a question that warrants a new video, I'll definitely post a new video as well.